All right, we're going to pick up where we left off in section 10.2, looking at plane curves and parametric equations. The last example we had done, example number 2, gave us a pair of parametric equations, and we created a corresponding graph, and we found out that depending on where we started, changed the graph a little bit on what it looked like. And initially, we all kind of thought it looked like half of a parabola, and it did. And then when we graphed from the negative side, we got a much more interesting curve that you see on the screen right now. What we're going to be moving into is trying to create parametric equations now. So, example number 3, we're going to find parametric equations describing the given curve. So I'd like for you to notice the syntax of this does not say find the parametric equations. It just says find parametric equations. And that's on purpose. That's because there's multiple answers. There's many answers that you could give. And so I'm going to show you one way of doing this, and we'll talk a little bit about how you might alter what you would do if you wanted to do something differently. But what I'm going to show you is one option on how to create parametric equations. So the one that we're going to look at, number 3, is going to be a line. So the line segment and we're going to go from the point 0, 1 to the point 3, 4. So a few details as we're thinking through this. Let's just look at x itself. So x goes from 0 to 3, and specifically it's in a line, right? And you know the basic equation for a line. So what is the basic equation for the line? Yeah, y equal mx plus b. So I'm going to use ax plus, or at plus b. I'm going to use t because we're working with parametric equations. T is our parameter. And we already had x on the other side, right? We're defining it for x. And we're going to use a and b just as general values that we're working with. It just matches what your book does. It doesn't matter. Use an mx and use an m and a b if you prefer. Because so if we let t go from 0 to 1, okay, so that's my thing that I'm creating. That's arbitrary. I've chosen for it to go from 0 to 1. Then x will equal 3t. So imagine if t is equal to 0, if t is equal to 1, my x will go from 0 to 3 like I intended, right? Okay, so x would equal 3t. This would start at 0, end at 3, specifically for x. Y doesn't do that though, right? So this is the x portion of it. So y goes from what to what? 1 to 4. So same thing, t can't be changed now. We've already defined that t is going from 0 to 1. So t is still going from 0 to 1. So what would y look like in terms of that parameter? It still has to increase by 3, right? 1 to 4 is an increase by 3, so my slope is still 3. But 3t won't do it. 3t plus 1 will. Yep. So we start at 1, end at 4. So one parametric equation, like pair of them, would be x equals 3t. Y equals 3t plus 1, and the t is going from 0 to 1. Now, can you imagine just changing it and deciding that t goes from 0 to 2? or 0 to 1/2? Sure. And if you did that, then it would adjust and change those equations by correspondence, right? Like correspondingly, it would change the equations. The statement at the end where the parameter is going from 0 to 1 gives us the piece that makes those two equations for x and for y work. So it doesn't have to be chosen 0 to 1, but 0 and 1 are really nice values. They're nice values to plug in for t, and so that's why they're being chosen. Okay? Any question on that? Because we're about to do a little bit more of an interesting one. This one's a little bit boring. Why? Because it's linear. Yeah, it's a linear one. That's why it's boring. So we're going to do one that's a little more interesting because it's not going to be linear specifically. So we're going to do the portion, same directions, the portion of the parabola y equals, 2 minus x squared. And specifically the portion that we're going to look at is from 2, -2 to 0, 2. And if it helps, you can draw a picture so you have in your mind what you're trying to create. So if we draw our graph, we have a parabola. It's opening how? Downward, thank you. And what does the 2 at the beginning do? Shifts it up 2. So the basic picture looks something like this, right? For the whole thing. But we're supposed to be starting at 2, -2. Whoops. So 2, -2 would be about right here. And we're supposed to be ending at 0, 2 up here. So the portion of the parabola we're talking about is just this portion that's not drawn to scale very well, but in terms of my hash mark there, it does not go through 2, 0, but is that all right? Okay, so it's going to bother me. Let's go with that. Okay, so the other thing to notice is that the starting and the ending point does not move from left to right like we sometimes do. It actually moved from right to left. So we have to keep that in mind as we're creating our parametric equations. We want the direction of the parametric equations going the correct way. So again, we get to choose. And so we're going to we could let, and this is what I'm going to show you, we could let t go from 0 to 2. If you don't want to go to 0 to 2, you can go 0 to 1. But I want to show you what happens if we choose 0 to 2. All right. Then x goes, from 2 to 0. Not because t did that, but that is simply what x is doing, right? I'm supposed to be starting at x equals 0, and 2, and I'm supposed to be going to x equals 0 backwards. So we need our x value to do the opposite of what the t value is doing. So we could set x is equal to 2 minus t. That'd do it, right? I start at x equal to 2. That would be at t equal to 0. And then when x is equal to 0, t is equal to 2. Let me give it vice versa. Okay, so when t is 0, x is 2, and when t is 2, x is 0. Will that work? That'll adjust my x values correspondingly. And we actually know an equation that gives us x and y's relationship. So we know y is equal to 2 minus x squared, right? That's the equation that we're sort of mimicking in the picture. So how can I figure out what y should be in terms of t? Yeah, right. So with substitution, my y will equal 2 minus, and then x is actually 2 minus t, so it's 2 minus t squared. We'll do a little bit of cleanup. So 2 minus 4 minus 4t plus t squared. 2 minus 4 minus 4t, plus 4t minus t squared. And I'll put my t squared first, 4t second, and then I have minus 2. And we could check this, couldn't we? So let's practice the checking of this again, since we did that last time in our calculator. So in case you've done anything since then, make sure your functions, or your calculator is in parametric mode, not function mode. And inside of your equations, we'll put the equation we just created for x and for y. So x is 2 minus t, and y is negative t squared plus 4t minus 2. Now your window will be important. We want our t value going from 0 to 2, and it should stop. Your t step needs to obviously be some sort of a portion of the number 1, so I've got mine set at 0.1 from something we did before, so I'm going to leave it that way. Negative 10 to 10 is fine. It's probably a little overkill, so if you want to do negative 5 to 5 on x and y, that would probably be sufficient. And then if you graph it, does it look right? Yeah. So you can use your calculator to check to make sure that the parametric system that you created will actually work for the parameters given. All right, so what we found out is that this parametric, this set of parametric equations works. So x is 2 minus t, y is negative t squared plus 4t minus 2, and this is for t going between 0 and 2. And again, if you wanted to choose something different for t, that's fine. It just means that your x and your y are going to change as well, and they all have to correspond to, they have to go together in order to create the correct graph. Any questions on that? Okay, did I write the homework down from 10-2 last time? I don't think I did either. So let me flip to another screen and we'll do that. The homework for this section is briefer than the last one. This is page 707. It's numbers 6, 9, 12, 14, 23, 26, 44, and 45.